Hi everyone, this is me Tini. Welcome to our next chemistry lecture. In today's lecture we are going to discuss about physical properties of oxide of period 3 element. Clear? Physical property of the oxide of period 3 element. Before going to start our topic, our lecture, I would like to tell it is chapter number 13 of second year, first chapter S&P block element, and our lecture number 5. 4 lecture already we discuss on these chapter in S&P block. So today it is our 5th lecture. In this lecture we are going to discuss oxide of period 3 element. Before going to start its physical property, I would like to tell what is oxide. Clear? What is oxide? The word oxide which is used, oxide, the binary compound of oxygen with other element. Binary means coupled, means oxygen react with other elements, so it form a compound or molecule that is called oxide. The binary compound of the oxygen with other elements are called oxide. It is definition of oxide. Example, that is sodium oxide and magnesium oxide, and so on. And next point, argon does not form an oxide because it has complete outermost shell. Clear? That's why it has no free electron, so therefore it cannot react with oxygen. Suppose we are going to discuss about period 3 element, that is from sodium to argon. Clear? 8 element it consists, but only the element that is argon which cannot react or which cannot do reaction with oxygen, so therefore it has a complete outermost shell, no free electrons to take part in reaction. So this was oxide. So let's see its physical properties. It has 4 physical properties. First one, that is structure of oxide. Clear? Structure of oxide. First of all, the sodium oxide, magnesium and aluminum oxide consist of joint structure of metals form. Clear? Here sodium, magnesium and aluminum, they have joint structure, means complex and large structure they have of metals from, such as like whenever magnesium and oxygen they react, in this case magnesium deliver 2 electrons and oxygen accept, so therefore it has negative charge, so therefore they form magnesium oxide. And second, silicon oxide or silicon dioxide has joint covalent structure. It has a covalent structure mostly, but in some cases it has joint covalent structure. Next point, but the oxide of phosphorus, sulfur and chlorine, they have simple molecules. Whenever these 3 molecules react with oxygen, when they combine with oxygen, they make a simple molecules. Clear? There they make complex molecules, but here they make simple molecules. Here they are in the form of metals, but sulfur, phosphorus and chlorines, they are non-metals. Clear? Large amount of energy required to break that, but here less amount of energy required. Clear? Here they are weak bond, they have weak intermolecular forces, but there they have strong intramolecular forces present there in sodium, magnesium and aluminum oxide, but here simple, not that much energy required to break. Clear? So this was our first physical property. Let's see second one, that is nature of oxides. What is nature of oxide? Here we discuss about its ionic and covalent properties. Nature of oxide, the sodium and magnesium oxides are ionic, they are in the form of ion. Clear? Ionic characters they have. Aluminum oxide has less ionic but more covalent in nature. Aluminum, they are mostly more covalent structure they have, but less ionic form. Third point, that is the oxide of sulfur, silicon, phosphorus, sulfur and chlorine have covalent characters. Here these elements, because they are non-metal, that's why they have covalent characters, but others, this above one, sodium, magnesium and aluminum, whenever they react with oxygen, they have ionic or more or less ionic characters, but these silicon, phosphorus, sulfur and chlorine, that's why they are non-metals and they are only covalent characters they have. Fourth point, the ionic character of the period element decreases. Clear? from left to right, from sodium to argon, the ionic character is decreases. So then which thing increase? While covalent character is increases. From sodium to argon, whenever the ionic character is decreases and covalent character increases here. Reason why they increase covalent characters? Reason due to the decrease in electronic duty difference. This is the point. Clear? Due to electronic duty difference, covalent character increases from left to right and ionic character is decreases. Clear? So this was nature of the oxide. Let's see third one, the melting and boiling point of the oxide. What is melting and boiling point? Let's see. The oxide of sodium, magnesium and ammonium have high melting and boiling point. In this point, sodium, magnesium and ammonium have high melting and boiling point. Reason, they are ionic and a lot of energy required to break the strong attractive force between ions. Ions that may be cations or anions, maybe they contain positive ions or negative ions. So large amount of energy required to break the strong attractive force between them. Second point, the melting and boiling point of silicon dioxide also higher. In this case, silicon dioxide also higher because it's also giant molecules and giant structure. It has a large amount of energy needed to break the giant ionic and covalent structure, as I told. Clear? They are giant ionic, that's why large amount of energy required to break this structure. So fourth physical property, that is electrical conductivity. What is electrical conductivity? Here we discuss about the free electron, those elements which have free, those molecules which have free electron, that in their current can easily pass. But in some cases, like the oxide of metals, sodium oxide, magnesium oxide and ammonium oxide, they don't have free electrons. They don't conduct electricity in solid state because they don't have free electron. In solid state, no free electron consists. In solid state, no free electron, no free electron. Reason, due to absence of mobile electron. Clear? Mobile mean free, no free electron in solid state. That's why no electricity can carry, no electricity can pass here. They cannot conduct easily, but conduct in molten form. Whenever they convert into liquid state, so they can easily, so it means free electrons can come here. Next point, the oxide of silicon oxide and phosphorus oxide, sulfur oxide and chlorine oxide do not conduct electricity in gas, liquid and solid. Sulfur, phosphorus, silicon and chlorine, they do not conduct easily in gas, solid or in liquid form because they don't have free electrons. Reason, none of them have free electrons and they are in the form of molecules. Whenever they are in the form of molecules, means they don't have free electrons to conduct electricity. So this was my lecture which I delivered in the print of you. That was physical property of the oxide of period 3 element. In lecture number 5 it was. So see, we will come in our next lecture, that is lecture number 6, and our topic is acid base behavior of oxide of period 3 element. We will discuss in our next class, in our next lecture. So see you, thanks for listening and watching. Share my video with your friend and your classmates. So thanks for